Well, welcome to the third part of our video here. And what I decided to do is break the videos into two separate parts. Actually, this is the second part. I've jumped way ahead of myself. As you probably already discovered, I'm not the greatest speaker in the face of the earth when it comes to doing things. I prefer to do things off of my own without a script. So I hope you forgive me for that, but I hope that also that you learn a little lot from this, and I will try to make this video as informative and as enjoyable as humanly possible. So we're talking about wireless networking. Is very, very, very comprehensive, but there are just a few things that are really difficult. The rest is pretty much straightforward. So we're going to get into that right now. So we're talking about the wireless network design. And again, there's two things. You're going to design either an indoor network or you're going to design an outdoor network. We are actually going to do both. So I'm going to give you some terms over here, and they're actually posted right into the videos there. The videos, I encourage you, if you're not watching the videos, make sure that you're doing it. Make sure you're taking notes. The videos do offer a way for you to copy the script in there, the interactive script, and that you can actually use that to study, which will be very, very valuable for you. So the first thing is we're going to talk about radio frequency, which is really just refers to the rate of oscillation of electronic radio waves in the range of 3 kilohertz to 300 kilohertz, as well as the alternating currents carrying the radio signals. That's a lot of mumbo jumbo to remember, but basically just think of the frequency as the way things and the width of the way things are being transformed. And here you have the Internet of Things, IoT, and definition of that is just the Internet of Things of physical network devices such as vehicles, home appliances, and any other items embedded with electronics and software, senses, and it has connectivity that allows you to connect and collect and exchange data. Then we have the world famous Z Wave, and again, it's a wireless communication protocol for communicating among devices used in home automation, which that one uses radio waves for signaling control as well. So then we have ANT Plus, and that's nothing more than a protocol that used to monitor sensitive data. And sensitive data uses 2.4 gigahertz, and has very fast transmission rates. So it is compatible with mesh topology if you don't have a very large network, but it can also be used as point-to-point, star, and tree. Then we have near field communications. Again, it's a lot like what it says. It allows you to communicate and share data with each other. However, it requires the devices to be within 4 inches apart in order to be able to communicate. So you can see, for instance, if you go to Starbucks and you have the Starbucks app and you print in your little barcode and you push it to a machine and boom, it takes care of it. If you go to Target or one of those stores, it gives you those little cards and it reads that card as well. So then we have spectrum analyzer, and it's any device that displays signal amplitude, which is really a strength, and varies by signal frequency. And you'll see the frequency on the horizontal range, and the amplitude is displayed on the vertical range. So now we have the actual design itself. I know I gave you a lot of mumbo jumbo terms. Those are the definitions of the terms. I can't really do anything about that. I will post a PowerPoint in addition to the live ones which I'm talking, which actually have these definitions for you. So now we have an actual design. So before you do a design, the one thing you want to do is conduct a site survey, which allows you to meet with shareholders. And you're going to just discuss the wireless network and how you're going to implement it, what you actually want to do, how you're going to gather information. You also need to know the number and location of the service areas, how many devices. And important, the one thing that people do tend to forget is what about expansion? So again, the first thing is you want to gather network and requirements. You want to identify the expectations. And so the first phase is, again, you want to map it on paper. Once you identify these things and gather the requirements, you need to put it down on paper. But remember that this is just a work in progress and it's going to be modified. Things you need to also look for, anything that could disrupt the radio signature, such as a building, a big tree, and so on and so forth. Here you have design considerations. And again, so you also need to really look at the hardware that you're going to need, and you need to identify the equipment that may already be in place to see how that's going to be used. Then you need to conduct your RF modeling and your mapping. And then next thing is you need to implement the wireless network. You need to understand bandwidth, how much bandwidth you're going to need, how many clients are going to do that. So here we have, make sure that you plan for it. And so now at this point in time, you kind of have a very rough draft, but remember you also have to consider weatherless. Suppose your system is in an area that has lightning all the time. It has tornadoes. It has a lot of rain. It has a lot of wind. All of these things are going to affect your condition. So make sure that you're aware of that as well. Then you're going to do the site survey. And here is the things you want. What is it for? How many areas? Where are the areas? How many devices? Future needs. Then what type of data encryption are you going to need? If you're going to be anywhere that the public is close and can be using packet sniffing, you need to have a very strong encryption. I recommend that you use at that point in time the Radius server in the enterprise. Okay, again, more considerations: environmental, physical, any kind of obstructions, future construction, frequency interference, mounting point available. If you're going to use an antenna, you have to mount it. It can't float on a balloon. Bandwidth. And then, of course, you have the city. Are you going to be allowed to do all these things? So again, we have a assessment information, the mounting, the media, the network hardware, and consider the initial RF model. So where the access point's going to go, where are you going to frequencies, what are you going to use, and how much power are you going to use, how much gain. Bandwidth, how much bandwidth, how many clients, what frequency, all those things need to be considered. So here we have something with thick walls. So we need to take a look at the signal strength in there. Also remember, distance has a big effect on your signal strength. The farther away it is, of course, it's going to weaken it. Here's your site survey. So again, a lot of this is repetition. Inspect the mounting location, identify, document structural and environment concerns, verify you can reach your wireless controller. So having a great access point isn't going to do any good if it cannot reach the wireless controller. What is the power and grounding available? What about your GPS coordinates? And take digital photos of the mounting devices. Again, you want to test the equipment. Obviously, you need to have 2 access points, 2 laptops. You're going to need a tall ladder, radios, and a spectrum analyzer. So here you go. You're going to mount, align, test, if you have to move and test. And the spectrum analyzer is going to really give you a lot of information. So here is the definition of good put: number of useful bits delivered from the sender to the receiver, and any kind of errors. Here is a spectrum analyzer. So you can see you're going to check the different times of the day to see what the utilization is. Identify sources of interference at each location where you plan to deploy the access point. You can use tools like NetStumbler to create a snapshot of your wireless spectrum usage in your area. It'll also show you how much nearby home and business networks are going to use and how close they are to your network. So you can see from this exactly what's going on. And then it can also provide a reading of the noise in the floor, especially if you have a basement and you have concrete that you need to go through. So you need to identify the minimum signal ratio the NSENs are to receive the signal level parameters, or the RSL. Again, here we have another diagram in here. So this is going to identify just how strong the radio signal is at the receiver. So the closer you are to the transmitter, obviously, the stronger the RSL, the farther away you are. the lower the RSL. So the SNR is going to measure the level of the wireless network signal, and again the RSL is going to measure the level of background noise in decibels, and it compares the management. Anything SSR higher than a 1-to-1 indicates more signal than noise, and that's really what you want. The farther away you get the transmitter, the lower the SNR. As soon as it falls below noise floor, then you're going to lose connectivity. So again, you want to have a channel plan. So these are 2.4 has 3 non-overlapping channels at 20. We talked about that as 1, 6, and 11. 2.4 has 1 non-overlapping channel at 40. So avoid 40 megahertz at 2.4 for the 801N deployments, because N allows you to access it at 5. And then you have the 5.4, 5.75, depending upon which one you have, can handle 40 megahertz channel bonding. Again, here we have IP address extreme and VLAN configuration in here. So you want to definitely take a look at that. Maybe you want to create smaller VLANs, and you might want to implement VLAN pooling. So how many wireless controllers are required? Again, these are things you need. How many access points? What media needs to be implemented? So a lot of this stuff, again, is repetition. So again, the site survey, physical network, RF metal, the analysis, your logical diagram, put in some photographs and diagrams, structural, alternate mounting locations, how much equipment and cost to estimate. Because all these great planning isn't going to do you any good if you don't have the money to do it. Now, remember, this is an environment that is enterprise, not something in your home. So in summary, you want to test the equipment. You want to test your procedures. Look for good put. Do your spectrum analysis, channel planning. Have your core network plan. Look at your equipment. Make a list. And look at your site survey. Now we have antenna types, and we talked about that before, the 2 types that we have. So the first thing we want is signal range. And basically, it's really important you understand to pick the correct antenna for the right application. And range is really one of the important things. So if you're working within a structure and you're concerned about signal emission outside the organization structure, then you need to have something with relatively low gain, something like 2 to 9 decibels. Now remember that you can modify them in cases in here. It allows you to set that. You don't want something traveling very far outside your building where other people can use packet sniffers or something like that. So basically, if something's 50 meters apart, then you don't want to use a low gain antenna. You really need to blast the signal between the 2 signals, assuming you're using antennas there. Omnidirectional spreads it out in all areas. So if you have laptops and you have the antenna in the middle, it's going to be able to access them all. And here we have a signal one that is just going to be very specific. It's a directional antenna, and it's only hitting that one laptop. So that's not really going to meet the needs of the other 3 laptops that are in here. But the good thing is the narrower the beam, the higher the gain, means longer range. So now we have another example over here. We have omnidirectional, but notice that it does come a little bit to the outside. So you have to be very, very careful of that as well. You may need to get several of the straight directional ones. And here's an example of that. So now we have 1, 2, 3, 4, 5, and it's hitting all areas in there, including in the middle. Here we have an example of an antenna on 2 different buildings, and that of course is a straight line. So now we're going to go into the implementation. So we need to have independent access points, and they're really where each one, the AP stands, providing separate wireless network in its own independent configuration. So they are limited mobility, and really they're very difficult to handle. Okay, we have hub and spoke, and we talked about that a little before. Hub and spoke configuration is a wireless controller that's connected to APs through a wired link. So the individual APs have very little embedded intelligence, and sometimes they're called as an LWAP, or a lightweight access point. Then we have distributed wireless mesh infrastructure, and these networks use a controller, but some of the intelligence is actually in the APs. Then we have wireless bridges, and they're used to connect wire to wireless networks together. So again, we have these different things over here. So this device here is going to work where you have a wireless access point, an Ethernet switch, and a router, and that's going to work pretty well in a normal network in here, which only has 3 or 4. So you can see you have the 4 access points. They all have the same SSID, and they're using the same channel, and they're functioning as the same IP network. So when one computer goes to the other, they're able to continue to connect. Here we have hub and spoke example. Notice that all the wireless controllers are connected to just the one wireless in here, which you're going to have DHCP. And depending upon if it's home, it's going to probably have its own firewall. It may have its own DNS server, and all these different things take into a factor into exactly what exactly you need to configure. Most of them have everything, so you really don't need to spend a lot of time and effort in doing that. Now, here's a problem. Suppose your wireless controller goes down. That means you lose your entire network. You have a single point of failure. Here we have the distributed wireless mesh. Notice everything goes through the controller, but they can also contact each other. That obviously is more configuration. So the wireless controller is down here, but they're still able to communicate. Okay, we have a wireless bridge that's used to connect wired or wireless networks together. And here is the example over here. So you have one on one building, one on the other building. Remember, you may need to get a permit to do that. You're also going to be affected by weather, such as heavy rains. And this is the end of part 2. So I certainly hope that you have gotten a lot off of this. I'm going to have a cup of coffee, wet myself, and prepare for part 3. So I hope you have a wonderful, wonderful day.